So we discussed this third problem in CAT2. So the cardinality of A is 25, cardinality of B is 40, cardinality of A union B is 50, and cardinality of B complement is 25. So the question is to find the cardinality of the intersection of A and B, then find the cardinality of the union of the cardinality of the whole set. Then second part of question 3, cardinality of A is 300, cardinality of A union B is 500, cardinality of A intersect B is 50, cardinality of B complement is 350. So the question is to find cardinality of B and then find cardinality of the union of the two sets A and B. So let's check the solution, or let's discuss the solution to this. In the first case, part 1, cardinality of A is given by 25, cardinality of B is given by 40, cardinality of A union B is given by 50, cardinality of B complement is given by 25. So the question is to find cardinality of A intersect B, and then number 2, cardinality of cardinality of the union of the two sets. It is always good to understand these things on a diagram, the so-called Venn diagram. So this is the universal set. This set A, and let's have set B. So if you partition this by A, B, C, and D, then this question means that cardinality of A, which is the black circle, is 25. So black circle is A plus B. So A plus B is 25. Cardinality of B is given by 40. B is this green circle. So if I take B plus C, I should get 40. Cardinality of A union B. A union B means part A plus part B plus part C. So A plus B plus C is given by 50. So then now, and we are being told that cardinality of B complement is 25. So B complement, remember, B complement means everything that is outside B. So B is the green circle. So what is outside B in terms of the labeling will be part A and D. So it means that A plus D would give us 25. So from these equations, if I call this one equation 1, this one equation 1, this one equation 2, this one equation 3, this one equation 4. So if I replace or substitute 2 in 4, so 2 is A plus B. So where there's A plus B, I replace by 25. So I'll have 25 plus C, I get 50. So it means that C be given by 50 minus 25. So C is 25. So the value here is 25. Then if I replace equation 3 in 4, I'll be able to get another unknown. So 3 is B plus C. So when there's B plus C, I replace by 40. So I'll have A plus 40 equals to 50. So A will be 50 minus 40, which is 10. So A is 10. So if I have A as 10, then I can get B from equation 2. So A, which is 10, plus B equals to 25. So B will be 25 minus 10, which will be 15. So where there's B, I get 15. And then the remaining value is D. So we know that A plus D is 25. So A is 10. So I add D, I get 25. So D will be 15. So this is 15. So therefore, the answer to the first part, A, the cardinality of A intersect B is clearly part B, which is 15. And then cardinality of the union of the two sets, cardinality of the universal set is A plus B plus C plus D, which is the same as A plus B plus C is already given by 50, then plus D, which is 15, then we get 65. So the answer here will be 65. Another way of getting these solutions, alternatively, we know that cardinality of A union B is given by cardinality of A plus cardinality of B minus cardinality of A intersect B. And in the question, I've been told that cardinality of A union B is 50. Cardinality of A is given by 25. Cardinality of B is given by 40. Then minus cardinality of A intersect B. So 50 equals to 25 plus 40, 65, minus cardinality of A intersect B. Then you make A cardinality of A intersect B the subject, which will be 65 minus 50, still gives you 15. And so then this is how you answer part 1. Part 2, we are interested in finding the cardinality of the universal set. So remember, when they give us cardinality of B complement, remember, if you draw any set, arbitrary set in the universal set, then if this set B, if you take B, which is everything within this circle, and this region outside, so this is what we are calling B, and what is outside that circle is what will be called the cardinality of the set B complement, what is outside the set B. So if I take what is in B plus what is in B complement, I get the total number of elements in the universal set. So when you have B complement, so the cardinality of the universal set is simply given by cardinality of set B plus cardinality of B complement. And cardinality of B is already given by 40 plus cardinality of B complement is given by 25. So this gives us 65. So you could either have used this inclusion-exclusion formulas, or if you don't remember the inclusion-exclusion formulas, you just draw the Venn diagram and try to use the statistics you have or the numbers you have to fill different parts of the Venn diagram, and then interpret the problem in terms of the regions within the Venn diagram. Next question was to solve the question, each student in a class of 35 plays at least one of the 3 games, football, hockey, and rugby. 22 play football, 21 play hockey, 15 play rugby, 10 play football and rugby, 8 play hockey and rugby, 6 play all the 3 games. So we are interested in finding the number of students who play football and hockey, but not rugby, only football, and then only hockey. And the question has given us a hint to draw a Venn diagram, and from the Venn diagram, interpret the 3 problems. So let's check the solution. So we'll say let let F be the set representing those who play football. Let H represent the set of those who play hockey. And let R represent those who play rugby. And because we have now 3 sets, you can draw this rectangle to represent the universal set. So this is the universal set. And then so we have, let this be the set of those who play football. Let be this, those who play hockey. And lastly, let this be the set of students who play rugby. And it's good manners to label these regions by small letters A, B, C, D, E, F, G, and H. And you see in this question, we have been told that each student in a class of 35 play at least one game among football, hockey, and rugby. So which means that all the students being considered, the 35 of them, they must be in any of these parts within the 3 circles. So clearly from that information, it tells us that the value of H is 0. So none of the students plays none of the 3 games. So the value of H will be 0. So that tells us that A plus B plus C plus D plus E plus F plus G should give us 35. Let's call it equation 1. Then we have been told that 22 play football. And in our diagram, football is this purple circle. So if we say A plus B plus D plus E, we should get 22. Let's call it question 2. Further, we have been told that 21 play hockey. So hockey in our case is black circle. So if we take B plus C plus E plus F, we get 21, call it 3. Another information is 15 play rugby. So rugby is the green circle. So which means D plus E plus F plus G should give us 15. So let's call this one equation 4. The other information is that 10 play football and rugby. So where F and R meet should be 10. F meets R, D plus E. So D plus E will give us 10. Call it equation 5. Next, 8 play hockey and rugby. H meets R with the value 8. F and R. So F not F and R. 8 play hockey and rugby. So H and R. So H, R meets E, F. This would give us 8. So E plus F is 8. Call it 6. Another information, 6 play all the 3 games. So 6 play all the 3 games. So all the 3 games should be where the 3 circles meet at E. So E is 6. Now we call this one 7. So we work from bottom up. So we start solving the unknowns from the bottom equation to the top equation. So here, the answer is 6. So from 6, we'll have F equals to 8 minus 6, which will be 2. So F is 2. And then from 5, D will be 10 minus 6, which will be 4. So D is 4. Then we have, so D is 4. So from equation 4, D is 4, so where there's D, I put 4. And then E plus F from 6 is 8, plus G, I should get 15. So 4 plus 8 is 12, plus G equals to 15. Then this tells us that G is 15 minus 12, which is 3. So I put here 3. Then B, we have no solution. So C, we haven't solved it. So then now from the equation 3, we have E is 6, F is 2. So which means that B plus C would be the same as 21 minus 6 plus 2 is 8. So B plus C is given by 13. And then from 2, we know that D is 4, E is 6. So A plus B would be given by 4 plus 6 is 10. 10 from 22 is 12. Now from equation 1, so we know that G is given by 3, F is given by 2, E is given by 6, D is given by 4. So A plus B plus C plus 4 plus 6, 10, plus 2, 12, plus 3, 15 should give us 35. So A plus B plus C will be 35 minus 15 is 20. So we'll have A plus B plus C is 20. A plus B plus C equals to 20. So call this one 8, call this one 9, call this one 10. So substitute 8 in 10. So means where there's B plus C, you put 13. So A plus 13 equals to 20. So A will be 20 minus 13, so which is 7. So where there's A, I put 7. So I put here 7. And then substitute 9 in 10. So it means A plus B is 12. So I'll have 12 plus C equals to 20. So C will be 20 minus 12, which gives us 20 minus 12 is 8. So where they say you put 8. Then if C is 8, then it means that from equation 13, B plus 8 should give us 12. So B should be given by, okay, so B plus C. So C value is 8. So this equation 8, so this will be 13. So B will be 13 minus 8, which is 5. So here we fill this as 5. So all the sections of the Venn diagram are correctly filled. So let's go to the questions now. Find the number of students who play hockey and football, but not rugby. So where F and H meet, but we exclude a possibility of that region being counted to be an R set. F meets H at these two sections, B and E, but then there's a restriction, not rugby. So R, this E will be counted to be in R. So the only required part will be this part B alone, because when you are in B, you'll not be counted to be in R. So therefore, the answer to that part is 5. So part 1 is 5. And then 2, only football. Only football from this Venn diagram means when you are in A, and the answer will be 7. So part 2 will be 7. And next question, only hockey. Only hockey means you are in H at C. So the value will be 8. So the answer becomes 8. Next problem, we have Joram's age is 3 times the sum of the ages of his 2 sons. After 5 years, his age will be twice the sum of the ages of his two sons. Find the age of Joram. So let's form equation from this information. So we've been told that Joram's age is 3 times the sum of ages of his two sons. So we'll say, let Joram's age be X years, and the sum of age his sons be Y years. So I've been told that Joram's age is 3 times the sum of ages of his two sons. So from that, it means that this X, which is Joram's age, is the same as 3 times the sum of the ages of his sons. After 5 years, so let's say after 5 years, so which is the same thing as saying X minus 3Y equals to 0. So call this one equation 1. After 5 years, we expect to have Joram to be X plus 5 years. And remember, so this is 3 times the sum of ages of his two sons. So there are two sons. So each of the two sons after 5 years will have gained 5 years each. So then, which means in total, it will be 10 years. So therefore, the sum, the ages of these two sons after 10 years, after 5 years, the age will be 3y, will be given by, so the age of the sum of the ages is y now. So after 5 years, each of the son will have gained 5 years. So plus the sum, which is y, so it'll be y plus 10. So because currently the sum at the son's ages is y, so there are two of them after 5 years. So assuming that, so we have A and we have B. So A will have gained 5, B will have gained 5. So the total, they will have gained all of them 10. Then you add to the sum, or add to the sum of the ages they are now, which is y. So therefore, this will be y plus 10. So after 5 years, the relationship among the ages of Joram and his two sons is that his age will be twice the sum of the ages of his two sons. So which means that this age of Joram, X plus 5, will be twice the age of the sons, Y plus 10. X plus 5 equals to 2Y plus 20. So X minus 2Y equals to 15. Call this one equation 2. Then solve 1 and 2 simultaneously. In fact, equation 1 is X equals to 3Y. So where this X, I put 3Y, so I'll have 3Y minus 2Y equals to 15. So Y is 15. And then X will be given by 3 times 15, which is 45. So therefore, Joram's age is 45 years. Since from the stem of our problem, we said let Joram's age be X years. Or Joram's can actually just add to make it more fixed. So Joram's present age is X years. So once you have the value of X, gives us the age of Joram. So therefore, Joram's age is 45 years. We continue the discussion in the next session.